And to close off the video for the first day of finding zeros of polynomial functions, let's have a look at this. This is going to be an interesting example. We've been given 1 0. We know that this polynomial will have 4 zeros. The 0 we've been given is complex. It was 3i. Now this, like an irrational one, this is going to have a partner. If you have a 0 that's plus 3i, you will also have another one that's minus 3i. So if I made those into factors, I'd have x plus 3i and x minus 3i. I've actually written those the wrong way around. This one would give you x minus 3i as a factor, and this one gives you x minus negative 3i, which is what gives you x plus 3i. Now what we could do with those, we know there's 4 zeros, and I could try and divide them out, but do you want to do synthetic substitution with this, with i's in it? Oh, heck no. There's a much easier way. We could multiply these together, and we'll get something that's quadratic, which we could divide out using long division, and we'll be left with something quadratic, which hopefully we'll be able to factor or use a quadratic formula to find out other 2 zeros. So first of all, let's multiply these together. Look, we've got difference of squares here. We've got a plus b, a minus b. So this equals a squared minus b squared, minus 3i squared. So this is x squared minus 9i squared, and remember that I squared equals negative 1. So what I've got here is x squared minus 9 times negative 1, which is x squared plus 9. Okay? So from the beginning, this would have been x squared plus 9. Once you get used to doing the difference of squares, you could practically do that just with maybe this one line of work here. That would take you straight to there. So I'm going to delete all this extra work. I really don't need it. Actually, I'm going to want to save this as a note to put online. So let's just save it all. Group it. Oh, I don't want that bit. Yuck. Let's group this and save it. Okay, that's where that came from. Just did that there. Okay, so now what I could do is I could do x squared plus no x's plus 9. I can divide this out by long division. This will leave something that's quadratic. We have sort of something to do with x4, and we're dividing that something to do with x squared. We're going to have something that's something to do with x squared, which I should be able to factor. So let's divide this out with long division. We've got 2x to the power 4 minus x cubed plus 50x squared minus 9x. Oh my goodness, this looks like it's going to be a long problem. Here we go. Take up a lot of space on the page. So that goes in 2x squared multiplied back plus 18x squared. Subtract, subtract, subtract. So that gives me minus x cubed minus 3x squared. Bring down your next one. Divide by x squared. That gives me minus x. Multiply it back. Minus 9x at the end. Then we're going to subtract, so we're going to add the opposite. Nothing, minus 3x squared, plus no x's. Bring down your next one. That's this one coming down here. and divide that by x squared. That gives me minus 3. Multiply it back. Awesome. And when you subtract that, you're going to get a remainder of 0. Those lines are the same. So we've got 2x squared minus x minus 3. So we have now got, if we wanted to factor this fully, f of x factored fully would be, well, partially factored. If we didn't want to show any complex factors, it would be x squared plus 9 multiplied by 2x squared minus x minus 3. And we're being asked to find all the zeros. Well, we found 2 of them, plus 3i and minus 3i. So the zeros from 2x squared minus x minus 3 will give me the other 2 zeros. It's a long problem, so let's factor that. Let's hope it factors nicely. 2x and x, 3 and 1. I'm going to put the 3 there and the 1 there. That gives me, if that one's minus, that one's plus, that does give me minus x in the middle. So my other zeros are this gives me x equals 3 over 2, and that gave me x equals negative 1. So there are 4 zeros. The one they gave us, which was x is 3i, was it? All the way back there? Yep. There's x is 3i, which meant that we also had x is negative 3i. And then we found 2 more, which are 3 over 2 and minus 1. We found 4 zeros. And it was a polynomial of degree 4, so we expect to find 4. There's one small last part to the lesson, which isn't too bad. Write a polynomial function of least degree with real coefficients in partially factored form with the given zeros. Oh my goodness, that's a long question, say. What we mean by partially factored is, for instance, in this last question here, this, when we say partially factored, we don't want to see something like this in your answer. We'd expect you to multiply those together to get this here. Okay? That's what we mean by partially factored. Get rid of anything that's irrational. So we want you to get rid of anything that's irrational or complex from what you see. So if I wanted to write out a polynomial, remember, give it a name, turn all the zeros you've been given into factors. So this would be x minus negative 3, x plus 3, x minus 1, with multiplicity 2. That means this has been squared. And then you'd have x minus 4i, and that one's going to have a partner, which would be x minus 4i, turns into x plus 4i. So my polynomial in partially factored form, I'm going to have to multiply these two together, and don't forget that's just difference of squares. So this would be x plus 3, x minus 1 squared, and this would give me x squared, it's difference of squares, x squared minus 4i squared, so that would give me x plus 3, x minus 1 squared. I don't have to multiply it out, I'm allowed to leave it partially factored, and this would turn into x squared minus 4 squared, which is 16, and I squared, which is negative 1. So if I multiply this by negative 1, that minus turns into a plus. Okay, so that's this one. And let's have a look at the second one where it says do not skip. Oh, that sounds ominous. Right, so this one, if you have a square root, remember, they always have a plus or minus. So this 2 minus I is going to be, that's like saying 2 minus the square root of -1. It also has one where there's a plus in front of that. So remember, these complex ones and irrational ones always come in a plus or minus, but the plus or minus goes in front of the square root part, not necessarily at the beginning of the 0. So my polynomial, let's call it g of x this time. We have x minus minus 1 is x plus 1, x minus 2, what we're writing is we're doing x minus the 0. X minus the 0 we're given. So we have x minus 2 minus 1i and x minus 2 plus I. So let's have a look at that in more detail. X plus 1, x minus 2, x minus, distribute that negative there, minus 2 plus I, and this one would be x minus 2, don't forget to distribute that negative, minus I. Now, what we have to do, we're happy with those first two factors, but these last two, we've got to multiply them together, which looks a little difficult at first until you notice something. They're identical, except this one has a plus here and this one has a minus here. So this is like we've got a plus b times a minus b, where our a is x minus 2. That is going to turn into, that's difference of squares. So what we have here is we've got x plus 1 multiplied by x minus 2 multiplied by, this is difference of squares, where our a squared is x minus 2, that's our a, square it, minus our b squared. And our b is I, and we need to square it. So let's clean that up a bit. We have x plus 1 times x minus 2, x minus 2 squared. Whoa, right, follow that out. You need to do some work off the side, then do x minus 2 multiplied by x minus 2 equals x squared minus 2x minus another 2x plus 4. So it is x squared minus 4x plus 4. So that was this pink part here. X squared minus 4x plus 4. Then we've got this minus here. And then we've got I squared, which is -1. And we are nearly finished. This turns into x plus 1 times x minus 2 multiplied by x squared minus 4x plus 4 plus another 1 turns into plus 5. And that it is. There's a polynomial in partially factored form where we got rid of any of the complex parts. And I think we're ready to move on to, yes, that's going to be day 2 tomorrow.